Have you always been wishing you had perfect comfort in your home? Tired of those hot and cold spots, musty odors, mold, mildew growing, or just muggy in the house? Well, this next series coming up from ProCalcs University is going to teach you all the things you need to know to have that perfect comfort. Hey, welcome to ProCalcs University. I'm Tom Platania, your host. Wow, what a weekend. Great weekend, feeling better. I was sick last week. My wife was sick last week. But, doing the stuff you should be doing, eating healthy, doing a little bit of exercising and whatnot, and try to get things going. So it was a great weekend. Glad to be back this week. You should be seeing this on Friday. We're going to be posting these again, these videos every Friday, and we're trying to work on getting a specific time that we're posting them. This way, there's some consistency. We're shooting for 10 a.m. Eastern Standard Time to get these up and running. We still got some legwork to do and getting some things figured out. But our master editor Marie is working tirelessly, and I'm trying to do a little bit better for her on these videos, so that I incorporate a lot into the video without her having to do a lot of adding and screenshots and different things like that. So this is going to be a series, and the series is going to be on creating perfect comfort in your home. And each video that we do is going to gear towards little things that you can do. Some are big, to create that perfect comfort in your home. And when I say perfect comfort, my wife's idea of perfect comfort is turning the air conditioner down to 65 degrees. So I'm all, but you can see I'm in South Florida, and it's 80 some 90 degrees outside. I'm in my house with a jacket, long pants, but we know, happy wife, happy life. But that's okay. I'm okay with that. I go outside, I got to undress, I got to take shirts and jackets and stuff off just to go outside, but it's fun. But what is your perfect comfort? And that's different for everybody. But there's some standard practices that we need to look into, like humidity. The higher the humidity in a home, the lower we want to turn the temperature to feel more comfortable. Why is that? Is when we get moisture on our skin, it doesn't allow our bodies to breathe. It doesn't allow the heat to escape or cool to get in or any of those transference. And we're going to talk about transference of heat today, and so that we can understand why load calcs are required. What's the purpose of doing a load calculation on a house? And I'm not going to get real technical. I'm going to use it in some basic terms. Now, if you are a more technical person, we are going to have courses that we're creating that are going to get real technical. And we'll have some links in the future videos once we get those all up and running that are going to go into some nice basic stuff, but they're going to go into some high level things that mainly HVAC contractors, architects, builders. But you know what? I know there's a lot of do-it-yourself homeowners out there that like seeing that stuff. So once we get that up and running, we'll announce it. All right, so moving forward today is going to be about why do we need load calculations? What's the difference? Years ago, somebody just came out, and as a running joke, the guy stands on the curb with a cutout of houses in different sizes, and he stands on the curb and he holds it up to the house, and whatever size of the cutout actually covered the house, that's the size air conditioning system. So you'd have a 2, 3, 4, 5. I'd stand on the curb. Oh, this house fits on the 3-ton, so it must be a 3-ton system. or the other one that a lot of you know is 300 to 400 square foot per ton, or 400 to 500 square foot per ton. Man, today, that is like a broken clock. It's right twice a day. And we've had some other videos about 400 to 500 square foot per ton. But these ones in this playlist are going to be more pinpoint to specific items within creating that perfect comfort in your home. So, ladies, if you're watching this video and you're not happy, you have these hot spots, You go from one room and you're freezing, you go to another room and you're sweating, or you're in different parts and it's consistent, or it's muggy, or it's humid, or your electric bill is through the roof. We're going to cover that in one of these videos throughout this series. So make sure you stay tuned. Hey, don't forget to smash the like button, subscribe to our channel if you like the topics that we've been talking about, or if you have comments about things that you want to hear or see us do on the videos, but also comments about the video. Hey, even if it's like, hey, Tom, you talk too much, or whatever the case may be, put them in the comment. Just be gentle to me. I'm getting older up in my years. I don't have the patience I used to, but, have fun with it, enjoy it, because that's what these are for. Is, we're not getting paid for these YouTube videos. I'm not doing it to get some kind of huge monetization. Yeah, I'd love to have 1 million followers, but that's not why I'm doing it. I'm doing it because throughout my 30 some years in the HVAC industry, I've come to enjoy taking the knowledge that I have and passing it along to others. So that's what's great. All right. So don't forget to smash that like button. Now, every week we're doing the hat challenge. So before we go into this hat, let's talk about the last hat that we did last week. How about that? All right. So did anybody guess this hat? That's right. This is a Harry Potter hat. And what does this mean? This, from my understanding, is the wand. This is the Sorcerer's Stone. And this is the cloak, the invisibility cloak. If you're Harry Potter fans, you probably are sitting there going, oh, you don't know what he's talking about. I might not know the exact symbol meaning, but this hat is defined by Harry Potter. And on the back of the hat, it says the Deathly Hallows. Okay? Now, here was the big catch. Where did I get the hat? All right? Now, a lot of people may have put in the comments that we got it from Florida at the Universal Studios or a shop or something like that. But no. If you've been watching our videos, we were talking about our travels where we went overseas to London, Spain, France, Italy, Greece, just all over France. I mean, it's all these places. We went to Ireland, we went to Bermuda, we went to Iceland. Well, we actually got this hat at the Universal Harry Potter Park in London. Now, this place is amazing. My wife must have taken 5,000 pictures of this place. She's a Harry Potter fan, and I am too, but nothing like her. All of the props that are in this building are actual props from the movies. And they have videos of the actors talking about them. It's absolutely mind-blowing. If you ever get a chance to go, you need to. They got cheap flights going over to London, as long as you got your passport, and it's really fun. I mean, you could spend days there. We got there about 9 o'clock, 10 o'clock, and we had to leave at like 4:35 to catch the bus, and we could have spent another whole day there. I mean, my wife was actually rushing through the end of it, taking pictures, not even getting a chance to absorb it and enjoy it. But anyway, that hat, Harry Potter, Deathly Hallows. So that was a fun little thing. So now let's talk about this hat, Majorca. All right, where is it? Obviously you can see the wording on it, so I can't trick you into not knowing what the lettering is. But where is it? And try not to use Google. I mean, everybody's gonna cheat, go to Google, but let's give you a little. Let's see, where are we at here? How about this? Look at that. That's where it is. So we'll see how you go. All right, so let's get back to business. All right, we had a little fun. Try not to make these too businessy. All right, so today we're talking about why do we need load calculations? What's the purpose of it? Let's understand it. All right, so I'm going to show you some pictures. And I have a software that we use here at ProCalcs called Wrightsoft. Now, there's other HVAC load calculation programs out there, but in all my years, I've used just about every one of them. And hands down, for everything that you can do with this, Wrightsoft software is second to none. I know there's people that are using other products. I'm not going to mention their names. There are other products out there that'll swear by them, but I've used them all. And now having an HVAC business that does work internationally and does 150 plus load calculations a month, we use this a lot. And there's pretty much nothing you can't do. Now, remember, just like any other software, garbage in, garbage out. So we have to train our people properly to know what they're putting in, make sure that the software is going to spit it out. So let's talk a little bit about why we need load calculation. So we have our house, and let's go to our house here. Okay. So we have our house here. Why do we need load calculations? Because of temperatures outside, hot or cold. All right. If you live in a cold climate, if you live in a hot climate, you live in a humid climate, if you live in a dry climate, doesn't matter. The whole purpose of the load calculation is every item, every type of material, from drywall to brick to wood to everything, any component, construction component, has a value, an R value and a U value, that determine how the air, the heat, and how much of it can penetrate that object, that piece of material, and how long it takes it to do it. All right. So without getting technical, if we got a wall in our house and it's 100 degrees outside, the load calculation is going to be able to determine how that 100-degree air is going to get in through that wall. Yeah, you think it's a perfectly sealed wall, but it's not. It's a heat transference. So, like holding a pot that gets hot, you're not physically putting your hand on the fire or putting your hand on the stove, but you're grabbing the pot that's transferring that heat through. And that's what we're looking at. So we have that transference. And the better the insulation, the slower that we can stop that heat or cold from penetrating, and then the difference of what is outside to then what ends up coming inside. And then once all of that is inside, the purpose of the air conditioning system or heating system is to now remove that unwanted. So let's focus on air conditioning to make it easier. We have the heat that comes into the home through all these components, the windows, the walls, the doors, the cracks, the crevices, all this stuff that we have, and it penetrates and it gets into the home. So the load calculation actually can tell us how fast and how much is penetrating. Okay, that's the purpose of it. Now, they used to do this manually, but software today is obviously much more accurate and a lot quicker. So what the software does is it determines that. But then what it determines is it says, hey, I got all this coming in. I need to get rid of it. So what do we got to do? Now we need to size an air conditioning system to be able to remove it. Now, in a plain sense, the purpose of the air conditioning system is to remove unwanted heat from the inside of the home and bring it outside. Now, we're going to have other classes that are going to talk about how it does that. I'm not going to focus on that here because the purpose of this video is to understand why we need load calcs. Now, with the software, with doing load calculations, and now the current, they call it manual J8. I don't want to get technical, but if you wanted to Google it, manual J8, there's a book that's about this thick that goes through all the calculations, all the understandings. There's a lot to it. But besides the walls and the ceiling and all this stuff, calculating the air, and also when the air goes through this ductwork we talked about last week, it does gain heat. So there's another factor that we have to determine how much is in there. The software does that. It determines based on the attic temperature and the outside temperature, the attic temperature, and the temperature of the air going through the duct. It can determine how that's going to affect the temperature. Okay? Other things in the house, everything that has a motor or some type of internal mechanism, including yourself. You have an internal mechanism. Animals have internal mechanisms. Toasters, ovens, stoves, refrigerators, appliances, no matter how small or how large, they all put off some type of heat. It could be minimal, it could be massive. Okay? So, the other purpose of the software or a load calculation is to determine how much heat it's putting out. Now, the average person can put out, depending on their activity, their weight, their age, and all kinds of different things, it can be anywhere from 300, and the term that you use is BTU. I don't want to get, again, I don't try not to get technical. It's a British thermal unit, but that's how we calculate the heat. It's an average person could be anywhere from 300 to maybe 700 BTUs just resting, depending on the individual. Now, as we walk, as we exercise around the house, we can put off more heat. Well, if I'm putting off heat, what happens to that heat? That has to be calculated into the load calculation to say, how do I get rid of it? Have you ever been in an area where when there's only 2 or 3 people, it feels very comfortable in there, but when you pack it in with 20, 30, 40 people, it's hot as bejesus in there? That's why. Because if you go from only 3 or 4 people with 1,200 BTUs of heat being penetrated or coming out, and it's cooling fine, and then you pack it in with 30, 40 people, do the calculations. That's a lot more heat. And that also has to come into consideration. But because it's such an infrequent event that it happens. Now, if you're looking at commercial and it's something they're loading up with people all the time, that's a different story. But in a house, you want to think about what is the norm going to be. All right. So the people, the appliances, the windows, the walls, even the floor, depending on the type of floor you have, could make a difference. Is the house on a slab? Or is the house on a basement that's below ground? Is the house on a crawl space? Everything that you can conceive of being open to the outside or creating some type of heat. Animals, cats, dogs. I don't know about fish. Actually, it's, I talk about that. I'm sure in some way that fish inside the water, but the water is the one that controls. So let's use fish. We'll put fish off to the side. Hey, you know what? I've never had to worry about a fish, but if you're out there and you like to really dig into things, go ahead and tell me in the comments if you find any data online that says fish actually can put off any type of heat. I don't know. That could be an iffy thing, but cats, dogs, birds, all these things that are in the homes, they are going to generate some type of heat, and we have to find a way to be able to remove that. Okay, and that's what the air conditioning system does. Again, for another time. So load calculations are what we use to determine. Now I'm going to show you the software that we use. Here we go. So this is called Wrightsoft. Now what we do is when we're designing is we'll actually take the drawing from the architect and we'll put it in the software. We retrace the house so we have the format of the house, and then we do all of our work inside to make sure the house is laid out exactly as the architect or builder or homeowner, we do a lot of work for homeowners, provides us. Things like the windows, so they'll show us the window, and when we put the window in, we're actually going to want to determine, okay, well, the width of that window is 7 feet, the height of the window is 4 feet. We also need to understand how far it is above the ground, because that helps us to understand the sun. Where's the sun going to hit that? Because just because air goes through, we also have to determine when we have that solar reflection, we got to determine at what angle, and that's what the software does, which is great. It determines at what angle that sun is hitting and helps to determine how much additional heat load is going to be added to that. Now, another big thing that a lot of people don't take into consideration, there's 2 things. One, we talk about the amount of trees and bushes and things around that. And if it's something substantial, we'll typically put it in. But here's the concern. If we focus too much on shrubbery that's fairly new or old, if that shrubbery ever comes down and it has like this big giant tree, and we've calculated that tree as providing tons of shade in that house, The problem is, if you ever take that tree down, that negates all of that shading, and you could have additional heat that's being penetrated from the sun that could cause some hot spots. So take that into consideration. If you do any outside major renovations, you may want to have a load calculation done just to make sure that it did not affect how much cooling needs to be, because there'd be nothing worse than having your perfect comfort in your home, having to chop down this big tree, or a hurricane or tornadoes come through and they rip that tree down, and now you have no tree and you got this big wide opening, and then you wonder why the house all of a sudden is not cooling properly. So we take that into consideration. But here's one of the other things. I have this house set right now. You can see here's my little compass. Right now, north is right here. So this is north. Okay, this is east, this is west, this is south. You can just basically, if you took this and laid it on the plan, that's the direction. And over here is what's called a load meter. So when you add these two numbers together, sensible, trying not to get technical, but sensible is what lowers the temperature, physical, actual temperature. Latent is your moisture removal. That's what takes the humidity out of the air. And if we have a more humid climate, we're going to want a system that is able to remove more moisture. Okay, again, we're going to get into that in other classes, but different systems can remove more moisture than others and can actually be better. So I might be able to go down a ton of air conditioning and have better moisture removal and cool the house more accurately than having to oversize it just to accommodate. So we take those things into account. But let's add, if we add those numbers together, what are we getting? About 22, 20, about 24, almost 24. Let's say 23.5. There's probably an actual somebody's going to calculate that on and say it's actually 24,632, Tom. But anyway, let's just call it 24 for discussion's sake. All right. So when we have the house facing north and south and east west, watch what happens. Look at these numbers. Watch what happens when I'm going to double click on the center of this, and what it's going to do is automatically position the house on the software to the absolute worst direction the house could be in for the biggest load. So watch those numbers and do the calculation. You can probably pause it once you get the new numbers. So I'm double clicking and watch. Watch it, see what that went up to? It's only a few thousand BTUs, but it's different just from the direction of the house. And it can make a huge difference. Well, let's look if I flipped it the other way. See, the latent doesn't change too much, but the sensible does. So but based on the direction. Now, the house isn't very big, and there's not a ton of windows. So imagine if the house was bigger, and there was a lot more windows, and they were taller, and there's tons of sliding of double door French doors and stuff like that. Those have the biggest. If we go to the breakdown here, you can see here's glazing. That's your windows in this house. So that is the biggest load in your home. And if that's the biggest load, that means that from yesterday, remember when we had those big old jalousie windows where they opened up and they were huge, and every time you closed them, they never had a perfect seal? Well, that's where you probably got the 300 to 400 or 400 to 500 square foot per ton. But nowadays, these windows are double pane, triple pane, argon filled, air filled, low E. They got all these fancy things with them. And they take those windows and they make them so efficient. You know, you may spend an extra $20,000 on getting better windows, but over a period of time, it's going to more than save money on your air conditioner, because one, you're going to be able to probably drop a ton to 2 tons less, depending on how many windows, from what air conditioning system you had. Well, there's thousands and thousands of dollars of savings right there because you were able to reduce the tonnage when it was time to change the system, as well as the energy cost. So all of these things come into play, and that's what the software, that's why we need a load calculation. And when you're renovating your house, it makes a difference. If you're making any big renovations to the home, you're ripping out windows, you're adding on, you need a whole house or room by room load calculation. Now, the whole house load calculation typically is good if all you're looking to do is get a general a load calc for the house. I'm not looking to look at individual rooms. I'm not looking to do duct work, because if it's not for duct work, I really don't need to worry about a room by room. I just need the exterior. I need the windows, the floors, the ceilings, and stuff like that. But if I'm going to have duct work added and a duct system, we'll talk about that, manual D. If we're going to have that added, then I need to make sure I have a room by room. Otherwise, we don't need room by room. You can just do a whole house. So if you're doing any renovations, if you're building a new house, it's actually required. It's mandatory in most places to have a load calculation, and it's getting more and more mandatory in different cities, especially some of your outskirts, which is good, because there's I've been in this business a long time, and I would say 80% of the HVAC contractors or architects or builders, if they are not required by code to provide a load calculation, they won't do it, because they got the HVAC guy out there, not everybody, going 400 or 500 square foot per ton. I've been doing these houses for years, and it's a 5 ton, it's a 4 ton. We deal with this all day long at ProCalcs. All right, here's a big example, and we run into this and we get a lot of pushback, but after it's completed, we get praise. Apartments, condos, think about it. And this is kind of just a common sense thing. If I have this apartment or condo and I have, let's say it's 5 stories, and I have my first, my second, third, fourth, fifth. My 5th floor has a ceiling and an attic that's open to the outside, right? My 4th, 3rd, 2nd, 1st, they don't have any ceilings because there's a conditioned room over top of them. Well, if we look here, my ceiling is about a quarter or less, about a quarter or less of my total load. But if I get rid of that, I have no ceiling load. That lowers my air conditioning. All right, what about the condos that are on the outside versus the ones that are on the inside? Now, the condos or apartments that I'm talking about are identical. Let's say they're identical. Same size, same layout, same amount of windows, same everything. Let's say I have condos on the outside, well, versus the inside. The inside one has got no ceiling. It's got no load on the left and right side. If it's open to the front and the back, it's open there, but it's got no floor load. It's got no ceiling load. It's got no wall load, so it's got no windows. Now I have these ones on the outside that have a wall that's adjacent to the outside, just like we talked about. You are going to have heat that penetrates that, so it's going to require more air conditioning. So the one thing we see when we have all this is they go in and they'll size one unit, whether it's the bottom or the top, and every other unit in the condo or apartment will get the same system. Because in their mind, it's a 1,200 square foot apartment or condo. It's the exact same as all the other ones. It's got to be the exact same size. No. We get in so much trouble, and that's why you end up with the ones in the middle where they cool down too quickly, they don't remove humidity, or the ones at the top are always hot because they didn't size it right. So load calculations are your saving grace, and you need to use them properly. If you ever have any questions about this, you can give us a call at ProCalcs, or you can email us at tom@procalcs.net. All that stuff will be down in the information with links to videos and different things like that. I hope you got some good information about why load calcs are needed and required. It's been great chatting with you. Don't forget the hat challenge. We're going to post that next week and give you some little tidbits about the location that we purchased it from, as well as, obviously just keeping these things going. Remember, we're going to be having some podcasts where we're going to be interviewing some industry leaders and different things like AeroSeal. Great new product that's out there. I think it's already revolutionized the building industry, and I think it's just going to keep growing, and it's going to be used more and more. So had some fun today, folks. I hope you enjoyed it as well. Don't forget to smash the like button. Don't forget to subscribe to our channel. And remember, you can teach the right person anything. You can't teach the wrong person anything. Are you the right person?